Okay, the second example for graphing a rational function, you always want to first start off by simplifying it if you can. This bottom can be factored and possibly cancel with that x plus 1 on the top, so I have to factor the bottom to check. If I factor the bottom, I'm going to get x minus 3, x plus 2. And as you can see, I don't have any common factors, so I can't really simplify this. So the major features that we want to look for: holes, x-intercept, y-intercept, horizontal asymptote, and vertical asymptote. Now, because we don't have any common factors, we have no holes. For x-intercept, the x-intercept is the value of x when y is 0. So if I plug in 0 for y, and I look to see what makes that fraction 0, remember, in order for that whole fraction to be 0, the top needs to be 0. So in order for the top to be 0, my x-intercept is going to be -1. And if you want to write it down as an ordered pair, it would be -1, 0. The y-intercept is the value of y when x is 0. So I'm going to plug in 0 for x and see what I get out for y. That's going to give me a 1 over a -6. That's going to be my y-intercept. My horizontal asymptote is going to be y is equal to 0, because if we look back at our 3 rules, or our 3 situations, we have the situation where the degree on the top is 1 and the degree on the bottom is 2, right? Degree is 1, it's x to the first, and the bottom is x squared, so that's degree 2 on the bottom. And so whenever the degree on the top is smaller than the degree on the bottom, your horizontal asymptote is going to be y is equal to 0, which, as I mentioned before, is the x-axis. Now the vertical asymptote is after simplification, you look to see what makes the denominator 0. And in this case, there's no simplification, so we can just look right at the bottom. We have 2 vertical asymptotes, x equals 3 and x equals -2. And don't forget that these are lines, so you'll always want to write them as an equation. Okay, so let's use this information to graph it. I'm making this on a scale of 1. Okay, so we have no holes to graph. For the x-intercept, it's going to cross at -1. So it's definitely going to cross the x-axis at -1. It's going to pass through that point. I have a y-intercept of -1/6, which is going to be really close to 0. I have a horizontal asymptotic 0. I'm sorry, a horizontal asymptotic 0, and then a vertical asymptote at 3 and -2. When you look at your vertical asymptotes, I want you to notice that it breaks up the graph into 3 chunks. I have this chunk here from -infinity up to -2. Then I have this chunk here that's between -2 and 3, and then this chunk here that is from 3 to infinity. So it breaks up the graph into 3 pieces. So when we go to put this in on the calculator, we want to make sure that we graph all 3 pieces. And when we go to put this in on the calculator, again, I can't stress this enough, when you put it into your y equals, you want to make sure that if you have more than one term, you have to put parentheses so the calculator knows what's in the numerator and what's in the denominator. So make sure when you put it in the calculator, it looks like this. In parentheses, x plus 1, then your division symbol, and then x squared minus x minus 6. When you do that, you're going to find that you have a picture that looks like this. It's got to pass through those 2 points because those are your intercepts. So for sure it needs to pass through those 2 points. And those arrows show me where the end behavior is on each side of the vertical asymptote. So if we go back and think about our arrow notation, just to review, this arrow right here means as x approaches -2, and I would say it's coming from the right hand side, because if I trace it, it's going to be coming from this side. Then we would say y is approaching positive infinity. And this arrow here would be the limit, or sorry, I'm getting into my calculus. I would say as x approaches 3, and that's going to be coming from the left, so that's going to be this side here. We would say 3 with a little minus there to symbolize that we're coming from the left, and I would say y approaches -infinity because that arrow is going down on that side. So another review of that arrow notation. Now, if I look at the rest of the graph and I finish graphing this, here it's going to flatten out here at my horizontal asymptote, and this arrow is going to come down here. And then on the other side, I have this arrow here. It's going to flatten out at 0, and then on the left or the right hand side of 3, it's going to go to positive infinity.